5, we need to implement the family tree. So we start with a family member node class. It will has ID, name, gender, age. ID can not should be unique, and it also has neighbors, which is a dictionary. The key is the neighbor's ID, and the value is the relationship it will has. And it has some getter and setter methods, and also add a neighbor, remove neighbor, and get a neighbor by relationship. This will return the neighbor's ID with that certain relationship we want. So with this node class, we implement a graph class. So it has nodes as a dictionary to store the nodes it has, and the key is the ID, and the value is the nodes, nodes objects. And it has a mapping which turn the relationship from a string into a integer. And we can see here even numbers are reversible relationships, like say A is B's sibling, then B is also A's sibling, and all the numbers are irreversible relationships, like A is B's parent, then B is A's child rather than a parent. Okay, and the methods like create a node, get a node by its ID, and create a relationship between node 1 and node 2 with a specified relationship. This will add a node 2 into node 1's neighbors, and also add the node 1 into node 2's neighbors with the proper relationship automatically. And then we have a method to relax the relationships, like disconnect node 1 and node 2, get a direct relationship. This will find if node 2 is node 1's direct ancestor or offspring, and we'll use two helper methods. These two methods will use breadth first search to find if node 2 is node 1's direct ancestor or offspring. If it's not, it will return 0, and if it is yes, it will return the how many generations node 2 is after or ahead of node 1. And get biological parent, it will check the node have the parent of that gender. If the yes, it will return his parent's ID, otherwise it will just return none. And get a biological child, just to get a child, no IDs. So edit a node, update the name, age, and gender, delete a node, delete with the specified ID. With this graph object, we are going to implement the family tree class. So it initiates with the class with the mapping, which is actually the same as the default one in relationship graph class. And it has get node with ID method, and other methods like create a member, edit member, remove member, and get direct relationship between node 1 and node 2. It will check if node 2 is node 1's direct offspring or ancestor. That's to say if they belong to the same immediate family. Create a relationship. We'll check if the relationship is within this range, and if yes, it will check if the relationship is complying to the 3 restrictions that we will set, and if it yes, it will just set that relationship. So the three restrictions are: first one person may not have any relationship with himself or herself. We'll check if node 1 and 2 are the same. And restriction 2, one person may have only one biological father and one biological mother. So it will check node 2's gender, and check if node 1 has already have the parent of that gender. If it is yes, it will return false. If it is not, it will return true. So restriction 3 is that one person should not have any relationship with his or her immediate family members unless it's an adoption. So it will check if node 1 and node 2 belong to the same immediate family. And also here it will check if the relationship is adoption. If it is not adoption and they are belonging to the same immediate family, so we cannot update this two nodes relationship to something because it's illegal or already exists. Then we create the sample family, this method. This will, according to the Word doc here, create 8 families, create members, create relationships in between. And yeah, here's a test of the restrictions. First, we create the family tree and set up the sample family, and then we test restriction 1, 2, 3. We want one to himself's sibling, which is illegal, and we want 7 to have 1 as his parent, but actually 7 already has a father, so 1 cannot be his father. This will violate the restriction 2. And 3, we want to update 1 and 12 to become marriage, but we will see that they belong to a same immediate family, so this is illegal. Let's give it a run. So we can see here sample family set it, and violate test 1 at restriction 1 that cannot have a relationship with himself. Member 7 already has a biological parent, which is the father, and 12 is 1's offspring, so and 2 generations after 1. So actually 12 is 1's grandchild. So the relationship that we want to set, which is marriage, is illegal. Okay. And finally, we create a CLI to add or edit or delete nodes. So it will first initiate the family tree and run a demo run. This method will just continuously asking you what action you want to take, and until you don't want to take any actions. And so the add node, this will check if the ID already exists. If it's not, then okay, take the name, gender, age, and change them into the format that we want, and create the member. Edit the node, check if the node you want to edit exists, and take the name, gender, age, and update it. And delete, check the member you want to delete exists. If it is yes, double check if you really want to delete. If yes, okay, delete it. We give it a test run. So first we add somebody, let's say 16, David Chipperfield, okay, male, and 50, okay, the member edit, and yes, continue. Then we want to edit someone, let's say ID 3, and Catherine, so let's say her new name is Kathy Show. Gender is fine, updated to 30 years old. Okay, she's updated. And okay, we finally delete the node that we just added. Yes, we are sure to delete. Yeah, it's deleted. Okay, that's it.